This is Mr. Weideman, Regular Physics, Lafayette High School. Homework problem number 47 from your problem set on gravitation and planetary motion. This is a really good problem. This is a challenging problem. There's no way that this problem can be solved by just plug and chug. We really have to take a look at the physics of what's going on. All right, I'm sliding a 10-kilogram block here on Earth across a smooth glass, and this is just a normal equilibrium force problem. It's at constant velocity, so I'm in equilibrium in all dimensions. So if I have a 40 Newton pull force and I'm at constant velocity, then my force of friction also has to be 40 newtons. Now what about the vertical dimension? All right, the vertical dimension is going to help us find force normal because my force normal is going to be equal to my weight. And then I can use that and I can calculate my force of, actually I'm looking for mu k in this case. All right, now I know we're all thinking about force of gravitation is equal to Newton's law of universal gravitation, and that will work. I can plug in the mass of the Earth and the radius of the Earth squared and all this other kind of stuff, and that'll work, but it's a hard way. Okay, we can just simply go m times g. It will give us the exact same answer. So I have everything I need to compute mu k. All right, now I'm going to take this same setup and I'm going to take it to Saturn. All right, now we need to think. Now when I go to Saturn, what is going to be different and what is going to be the same? All right, so here's our same setup, but now I'm on, Jupiter, not Saturn. But remember, our physics tells us that mu k is a function of the material type. So it's still the glass and it's still a wooden block, so that mu I computed on Earth is going to be just fine for Jupiter. So mu k is not going to change. But the force applied is going to change because the force of friction will change. It'll still be in equilibrium, but why will the Fp be less even though mu k is the same? And the answer is what is happening here in the vertical dimension, and that is force normal. Force normal will change because the force of gravity on Jupiter is going to be different. Now, I don't know what little g is for Jupiter. I could compute it, and that would work, or I could just use Newton's law of gravitation. And I can look up the mass of Jupiter. I can look up the radius of the planet Jupiter squared. All right, what's your units? Kilograms, meters. That will allow me to compute my weight of the 10-kilogram block on the surface of Jupiter. That will allow me then to find force normal, and then I can use mu k for my Earth calculation and find my force of friction. My force applied must be in equilibrium with my force of friction, and that will solve the problem. All right, just plug in the appropriate numbers and understand what we're doing here, and you'll be good to go.